let's use some quadratic equations to solve some real-world type problems. Okay? Producers for a Broadway musical notice that increasing ticket prices can generate more revenue, but only up to a certain point. At $50 per ticket, the expected revenue is $38,250. At $100 per ticket, the expected revenue is $49,500. At $135 per ticket, the expected revenue is $39,150. Okay? So what quadratic function can be used to relate the ticket price and the expected revenue? So there's two ways that I'm going to show you today to do this. Okay? Method 1, method 2. Got it? The first method deals with using matrices in your calculator. Now, we obviously don't have an 83 calculator, so I'm going to have to show you some different ways than the screenshots that happen to be down here at the bottom, but it's not a big issue here. Okay? First, let's fill out our table up here. If we have $50 in ticket price, what is our expected revenue? $38,250, right? $38,250. If our ticket price is $100, what's our revenue? $49,500. And do we know any more information? At $135, our expected revenue is $39,150. Right? We don't need the dollars in our table, but we know that's money, right? So we have to have 3 data points. It says you must have 3 data points. Why do you think this is? If we only have 2 points, what do you think? Pardon? Why wouldn't it work? What happens when we have 2 points? It's a line. We have to have that 3rd point to know what shape where it goes. Okay? Does that make sense? So when did we use matrices last? We used them to solve a system of equations for A, B, and C. So if we have A, B, and C that we're trying to solve for, how many equations are we going to need? If I have 3 variables, I need 3 equations, right? Exactly right. Okay? So to get the 3 equations, we're going to use standard form. Ax squared plus bx plus c equals y. Fair enough? Everybody remember where that comes from? Good. So here's the point. We got this from our table up here or from our paragraph. Okay? The point is 50, 38,250. So what did this example show you to do with the 50? Isn't it the x point of the, or x part of the point anyways? So doesn't it make sense to put it in for x? Okay, so 50 squared, oh, another x, so I got to put it in again. C doesn't have an x because it's a constant. And then, wait, why is this here? Because it's y, and it equals y. Does that make sense? Now we have to simplify it. Where in the world did they get 2,500? 50 squared. Isn't that 50 squared? 50 times b is the same as b50, right? And then c, and then our y value. Can you replicate that on the second one? We substituted in 100 for x. So we get a times 100 squared plus b times 100 plus c equals the y value. So how are we going to simplify that? Uh-huh. 100 squared times A plus 100B, good, plus C, 49,500. Okay so far? So what about this last one? What are we going to do? So A times, what am I plugging in for x? The x value of the point, right? So 135 squared plus b times x, which is 135, plus c, no x there, it's just the constant, equals 39,150. Now, simplify it. 18,000, what'd you say? 225, A, very good, plus 135, well, what is that? Sorry. 135B plus C. Very good. Okay. Now, it has been a while since we talked about matrices. It was last year. So let's go home. Not literally, because I'd like to as well. New document. No, I don't want to save the old. And I want to make a what? Just a calculator, right? Anybody remember where we go to start a matrix? Menu, matrix, right? 7. Oh, we want to go to 5 first, don't we? Because we're eventually going to take the reduced to echelon form. But now we need to go back to menu and back to matrix. But this time we're going to choose create. We have to create our matrix. We have to create our what? Oh, a matrix. How many rows do we have in our matrix? 3 rows. How many columns do I have in my matrix? 4. And then OK. Oh, look at this beautiful matrix it created for me. I'm going to zoom in just a little bit so you can see what I'm doing. Okay. I need to take, wait, where did this matrix come from anyways? I know it's on the paper, but you're not always going to have it on the paper. Where did it come from? What do you mean up there? Like on the ceiling? Oh, the simplified form. But it doesn't say the same thing. Is it supposed to be exactly the same? Will this have an A? Or a B? Or a C? Because what am I taking from the simplified form? Only the coefficients and the constants. Okay? But if I take the coefficients and the constants, it's still not exactly the same because look right here. These are good. Uh-oh. Those are clearly not exactly the same. Except, isn't 135 squared 18,225? We just wrote it out. They didn't. Okay? And I think they're trying to make a point there, and even if they weren't, I'm going to make a point with it. We can put in 135 squared. We could put in 100 squared. We could put in 50 squared. It will do the math for us. We don't have to worry about that. But if you want to put in 2,500 and 10,000 and 18,225, that will work also. Okay? Oh, what the heck happened to my calculator? Sorry. It's mad. I started to use it and then I put it aside. That was disrespectful. Okay? So do you have all your numbers into your matrix yet? I clearly don't, but I'm waiting. Matrix, reduced row echelon form, menu, matrix, create a matrix that is a 3 by 4. So we're here, yes? So 2,500, tab 50, tab 1, tab 38,250, tab. Ooh, I'm going to be a cheater, and I'm just going to put in 100 squared. What? 100, 1, 49,500. Okay, so is my matrix good? So look what awfulness happens when I hit enter. I need the decimals, don't I, here? So instead of pressing enter, I need to press control, my blue button, my control enter. Oh, isn't that so beautiful? It's still really messy, but it's not fractions that I have to deal with here. And it's not that I don't want to deal with fractions, because fractions are your friends. Okay? But we really need the decimals here for this kind of equation. Okay? So what it looks like then, oh look, it looks exactly like what they told us it would look like, doesn't it? Now, ours rounds to 2 decimal places in these second two, so it's slightly different than what they have written, but it's okay. So remember, if this diagonal is 1s, that means I've solved for A and B and C. Do you remember that? Okay. So what is A? What's the value of A? Yeah, I know it says. Say it anyways. Okay. What's B? $1,143.91. I mean, that's what it says in our calculator, 91, right? What's C? .25? We good with that? So if that's A, B, and C, go back up here, and I can write my equation, right? If I know A, B, and C, can't I write my equation? A x squared plus b x plus c. Done. That's how you use a matrix to find the equation of a quadratic. Fair enough? There is another way, and I do want to show you. However, we cannot use these screenshots because they're not the same in our calculator in the Inspire as they were on the 83. Okay? So this is what we're going to do. We're going to go to make a new document, because this time what we need is a lists and spreadsheets document. Okay? Now, what is my X column all about? Price. P-R-I-C-E. Go away. No. Okay. If my X column is all about price, what do I do with these prices? Yeah, I put them in, don't I? 50, 100, and 135. We good? What's my Y column all about? Revenue. R-E-V-E-N-U-E. Do you notice how when I'm putting it in, the letters are in italics, but when I hit enter, they go to regular, like a regular font? That means the calculator has saved that word as a variable now. Okay? So what about my revenue? What goes here? Same thing that was in my table, right? Everybody have this? So take just a minute and make sure that mine is the same as yours, and make sure that ours is the same as the table up at the top of our worksheet. Okay? Are we good? Okay. Now, what we want to do, I'm going to scoot the calculator up so you can actually see what I'm doing. I'm going to zoom out just a little bit. What I need to do is I need to use this data in a graph. But I don't want to use like a regular graph. I need a data and spreadsheets graph. Data and statistics graph. So I'm going to press Control, my blue button, and plus page. I'm going to press doc. What kind of page do I need? Okay, do you see how at the very top I have 1.1 and then 1.2? So this is all using the same data. So when I create a data and statistics page, I should have 3 dots. Yours may look different. Your 3 dots may look be in a different place on the page. Are they? Okay. Now I'm going to move my cursor down to the bottom of the graph, and suddenly a box appears like magic. What goes along my x-axis? So if I click in that box, look what comes up. Price. And I can press enter. Oh my gosh, they moved by themselves like magic. Then I'm going to move my cursor over to the side of my screen where what should be? The y-axis, and I'm going to choose revenue. Exactly. They moved all by themselves like magic. That's the hard part, guys. That's the hard part. Because watch what happens now. Do you remember what this one's called? A regression, right? Look what happens when I press menu. And we want to analyze our graph. Look at 6. Regression. What kind of regression? Quadratic. Bam! What is the equation of this quadratic? It says it right there, doesn't it? It tells you what the equation was. And surprise of all surprises, isn't it exactly the same as this one we just got? Shouldn't it be, though? It's the same data. Shouldn't I get the same equation? Yes. Okay. So I gave you 2 worksheets today. One's called Using Quadratics, and one is called Solving Real-World Problems with Quadratics. Okay? So if it gives you a table, guess what I probably want you to do with it? Either find a regression or use a matrix to find the equation, because that's really what it's asking for first. Determine a function, a quadratic function, or a quadratic equation. So that's what's going to go first. Okay? Chances are you're going to need another piece of paper to do your work on. Okay? There's only one person that I have in class that can write this small, and she's not in this class anymore. Okay? So use another piece of paper. If it tells you the diameter, diameter of the pizza, what can I do with 16 once I get an equation? Diameter is x. Can't I plug 16 in for x to find my price? Yes. If it tells you the cost, can't I plug this in for y? And solve for x, right? Then you'll have to sketch a graph. Well, if you've done this way, don't you already have a graph? Okay? And then it talks about y-intercept, and it talks about what is in the real world and why is it greater than 0. Those are all questions you need to answer. Okay? You have 1 through 5 on this page. I know there's quite a few different questions within a question, 5 or 6 or 7 questions within a question. So I'm going to give you the rest of the period to work on this, and whatever you don't finish is homework. Okay? Any questions about this?